Right, virtual friends, if you haven't already, make sure you submit worksheet 1 through 3 through Schoology. And then, yes, everybody on test day next week, so Thursday, worksheets 4 through 7 will be due. In theory, 4 is already done, right, because you did that yesterday, maybe. Let's take some questions from worksheet 4. Graphing rational functions. Lots and lots of graphing rational functions. Yes, ma'am.
I don't understand how to find another point on the graph.
Okay, so you get to the end, and you're like, I'd like to have some more information here.
I get the x and y, I just don't know how to find another point.
So the good thing about that is all you have to do is pick some value of x and plug it into the original. Any value of x you want. So pick one where you're not sure where something's going on. Like pick one you want to find, and then plug it in. That's all you have to do.
Like into the original.
Into the original or the reduced. Like if it has a hole and you cross one out, you can put it into the reduced.
So just into the factor form.
Mm-hmm. Is there one where that happened on? Because I do want to work one from start to finish. Let's see. Somebody got a preference on which one we work? I want to work one of the graphing ones. Start to finish, like 7, 8, 11, or 12. Let's see. How about 12? Because 12 has 2 vertical asymptotes. I don't think we saw that yesterday. So let's do number 12. By the way, notes today are relatively short, and if you're decent with numbers and number sense and squares and square roots, homework's relatively short as well. So it's a good Friday lesson and assignment. Number 11. No, number 12. Because I want 2 vertical asymptotes, because we haven't seen that yet. So factor the top, factor the bottom. You've seen me do this, you don't have to do that, but to me, chunking the problem kind of makes it more, approachable. The fact that there's 3 chunks to the problem, rather than, there's 7 things I have to find. No, there's 3 chunks I have to find. I don't know, it's just a brain trick that helps me. X can't be 5, X can't be -1, because those are either holes or vertical asymptotes. Do we have any holes? Why not? Good, no factors canceled. So, and then here's why I picked this problem. Both of those are vertical asymptotes. So I don't know that we've seen one that has 2 vertical asymptotes yet.
So x for the denominator is vertical, not the top can be the other ones.
When the top is 0, that's going to lead to one of these intercepts down here. But it's probably best to just answer the questions in order, because we're always going to ask the same questions in the same order. So you get maybe a little bit of a routine on what you're looking for and what you're finding. Horizontal versus slant. Remember, there's always one or the other, never both. Is this a Bobo, a BOTS, or an EATS DC problem? EATS DC, because the exponents are the same. What does the DC stand for? Divide the coefficients. So what happens when I divide the coefficients? 1. So is my horizontal asymptote 1? Yeah. What's not quite right about that? Y equals 1. And then there are no slants because it's not BOTS.
How would each DC ever end up not being 1?
If this had a... Look at number 11. If we each DC on number 11, it would be 1/2 because the lead coefficients. So good question. You do each DC when the exponents are the same. Back to number 12. Y-intercept is set x equal to 0. And I can plug it into either the original or the factored. I think factored is easier. So I get 0 in the top, which means I don't really care what's in the bottom. 0 over -5 is 0. X-intercepts will set y equal to 0. And what makes a fraction equal to 0? The top being 0 or the bottom being 0? The top. So I don't really care about the bottom stuff. So x equals 0 is one of them.
And then x equals -2.
And -2, 0 is the other one.
Right here.
So let's put all of that stuff on our graph and see what we know. So domain can't be 5 or -1. That doesn't really go on the graph, at least directly anyway. No holes. Vertical asymptotes at x equals 5. And x equals -1. So this is, again, here's the reason I picked this problem. Because there's two vertical asymptotes. Horizontal asymptote at y equals 1. Y-intercept at 0, 0. And an x-intercept at -2, 0. Well, and 0, 0, but we already have that point. So this one has 3 branches to it. Usually they only have, I shouldn't say usually, when we had one vertical asymptote, it split the graph into 2 pieces. Now I've got 2 vertical asymptotes, so I'm going to have 3 pieces. The leftmost piece I feel pretty good about because I got 1 point. It's tucked in close to the asymptotes. I'm pretty sure I know what's happening there. The other point's like it's just sitting there. So what's going on? Let's pick some more points here. Right? Like this is the Haven's question from earlier of like I need more points. Like that's not enough. So let's go x equals 1 and see what happens. So 1 times 1 plus 2 is 3 over -4. I still need more information. I'm going to skip over 2, 3, 4. Let's try x equals 4. Maybe that'll be a better answer, or a nicer answer. So 4 times 6 over -1 times 5. So that's 24 over -5. 24 divided by -5. What's that equal to? Sadness. It equals sadness. -4 and 4/5. So 4, comma 1, 2, 3, 4 and 4/5. Okay, I feel better now about what this looks like. Asymptotes work a little bit like roots in that they usually alternate. The graph usually alternates across an asymptote. So if this side's going down, this side's going up. Then I can kind of fit it to my other points. The insides in there may not look exactly like that. I probably should have picked, I could have, not should have, could have picked more points in there, but I got the feel for it. There's one more spot I need to know what's going on over here. So what value of x should I pick for that? Yeah, 6. I meant x equals 5, so let's do x equals 6. Well, we haven't done many of these. Do you think this last branch is going to be above or below the horizontal asymptote?
Probably above.
Above, because they switch when you cross an asymptote.
It's gonna be
So if I plug in 6, I get 6 times 8 over 6 minus 5 is 1. 6 plus 1 is 7. 48 over 7. More sadness, maybe. What's 48 divided by 7?
just
What's it almost equal to?
7.
Yeah, it's almost 7. And for a graph, that's going to be good enough. Right? When you first learned 48 over 7, you could not have gotten away with saying, oh, it's almost 7. Like, but for this, it's fine. 1, 2, 3, 4, 5, 6, almost 7. Now, we've done enough. We know what that looks like. If you want to plug in 7, 8, 9, 10, yeah, exactly. No, thank you. You can. Your graph would be more accurate than mine.
So will the middle one always be cubic?
Will the middle one always look like, I want to say look like, because it's not a cubic, but it looks like a cubic. I don't want to say always, because we could rig it so that it does something like that. So not always. The other observation that I think I heard Tyler say is, what happened in here?
I just wasn't looking at it.
It crossed an asymptote. And math teachers, at least when you're not in pre-cal, we don't explain this very well, because we like to say, you never touch an asymptote, right? You never get there. You're like, well, that's true at the extremes. That's true for, well, it's not even true at the extremes. You can cross a horizontal asymptote. Just cut to the chase. You can cross a horizontal asymptote. You can't cross a vertical asymptote because we said x can't be 5 or negative 1. So you can't land at 5 or negative 1. But you can cross a horizontal asymptote.
Now does it reverse that middle one and like on the top and then do the same thing and then just squeeze through the other side?
Wait, say that again?
Just like the one in the middle.
This thing in the middle, the branch in the middle.
Flipped it over that point. Just reversed.
So if it did this, I guess I don't know what you're asking.
As if you flipped over your papers, like spun it. Would you have to do that or just that one?
We're not going to have to do whatever you're asking about. All right, do we need to do a slant asymptote?
No.
There aren't any that you had to graph, but there are a couple questions about find the slant asymptote. Do we need to do 9, 10, 13, 14? So how do you know? It's a good question. How do you know that's going to be a parabolic one?
Because it's bigger on the top.
Well, 13's bigger on the top, and it's not parabolic.
It's got an even exponent thing on the bottom.
When I divide x cubed by x squared, I don't know what else is going on, but I'm going to get something with x in it. If I do an x cubed divided by x, I'm going to get something with an x squared in it. So I can know right away that number 14 is going to have a parabolic asymptote. Of course, it says it right there too, but the reason we know that is the top is 2 bigger than the bottom. Bigger on top, slant. You can add to that acronym. If it's 2 bigger on top, it's parabolic. Can I synthetic divide with this one?
Because it's got the extra.
Yep, so 1, 0, 0, negative 2.
Negative.
And negative 1 will be my number I divide with. Copy down the 1, multiply, add, And again, somebody noted yesterday,
Like 3.
I can just stop there, right? Because we already know the remainder doesn't matter. So the rest of this problem doesn't really matter. It feels a little bit odd to stop there. But all we're going to do is throw the remainder away anyway. So we started with x cubed, we divided by x, we've got x squared minus x plus 1. X squared minus x plus 1 would be b. Remainder doesn't matter. Alright, do you feel okay about ones like 7, 8, and 11? Where you got to answer all the questions, put it on the graph?
Sure. Maybe.
Yes, no?
We'll find out.
We'll find out next week for sure. Hope the answer is yes.